Now we're going to look at patient A. With patient A, if you look carefully, you'll see that there is an extra chromosome 13. So in my notation, I'm going to say that there is an extra chromosome, so the total chromosomes add up to 47. And I notice that this is a female with 2 X chromosomes, X, X. And I'll put a comma and I'll say plus 13 to let us know that this individual's extra chromosome is at location chromosome 13. Now, babies that are born with this usually only survive a few days. This is a significant chromosome. How you would end up getting a karyotype like this, how this fertilized egg down here would end up looking like this karyotype is what we're trying to diagram here. So start by diagramming what most of the chromosomes are going to do. Most of these chromosomes up here will go through a very normal process, and we'll do chromosome number 2. Chromosome number 2 starts with 2 copies. They divide. And you end up with 1 chromosome 2 in each of the gametes. And that means eventually with fertilization, the mother will give 1 chromosome 2, the father will give 1 chromosome 2, and when they come together, we have 2 copies of chromosome 2 in the fertilized egg. And that's what you see up here in the karyotype, 2 copies of chromosome 2. But what about this chromosome 13? How did it end up like this? Well, at some point, a non-disjunction event had to occur, and it had to occur with chromosome 13 in one of the parents. So you start off with 2 copies of chromosome 13. Now for patient C, I ended up doing this in meiosis 1. We're going to do meiosis 2 for this example, but just know you could do this either way. It could happen either way. But in this case, I'll say initially things go just fine. They divide. But then in the second meiosis, that's when we start to see a problem. These 2 stick together, but these 2 go along just fine. So now, when we're identifying these gametes, we would call this one an N plus 1 because it's got an extra, this one an N minus 1 because it's shorter chromosome, and these are both N's. We would talk about, now again, we could say this is either from the mother or the father gave this child their problem. So in this case, we'll just say this extra chromosome 13 might have come from the dad. In this example, it could go either way, which meant mom gave 1 copy of chromosome 13. So together, when they were fertilized, you ended up with 3 copies of chromosome 13. So mom gave an egg that was N, dad gave a sperm that was N plus 1, and you ended up with 2N plus 1 when you added those together.